What's going on, guys? In this video, we are going to be learning about the Python image library, also known as PIL, also known as Pillow. So what PIL is basically an image processing library in Python. And what I mean by image processing is it allows you to manipulate images, make changes, play around with images, and do all sorts of things with images. So we're going to be learning about this, and this is going to be a fairly comprehensive tutorial on PIL. Alright, so let's just get started. We're going to import the necessary imports. So from PIL, we're going to import image, which is like the main component of PIL. And with image, you get to create an image object, and then you can manipulate the image object with different methods. Alright, we're also going to be importing matplotlib because when you display an image in PIL, it usually uses your default operating system's application. So whatever you're currently using on your operating system to view images, that's going to be opened up. However, for the purpose of this tutorial, I want everything to be contained within Jupyter Notebook, so I'll be using matplotlib to open and display images. Then we have NumPy, and we have matplotlib inline just to be able to show all the images with IamShow. Alright. So now we have the first method, which is just going to be creating an image object. So image.open, and then you feed in the path to your image. Here I have two images, so I'll run both. So now I have two image objects. So the first thing we want to do is we want to display the images. So let's see. So this will usually open up your default operating system image viewer. I'm not sure where it's going to open up in my case. Alright, not sure exactly where it opened up, but since I have everything set up in terms of the screen, I'm just going to ignore that for now. So we're going to open up the two images within our Jupyter Notebook. So we have a cool looking cat, and we have the sky. Alright, so when you have an image object, you can also display the properties of an image. So let's just run this. Alright, so here we're displaying the size of the image, the format, which is a JPEG, and the mode, which is RGB. So there's various different modes like HSV, which stands for hue saturation values. Then there's CYRB, I think. So yeah, there are various different modes, various different color modes for images. And these are just some of the properties. Okay. Now the 867 by 1300, let's just go up. So the 867 represents the width and the 1300 represents the height. So the way the image size displays the dimensions of images is width by height. So with NumPy, you usually have rows followed by columns, but with PIL, it's columns followed by rows. So just be aware of that. Alright, number 4, saving an image. You can save an image with image.save, and you feed in the path to the method. So image.save will save the image as newimage.jpg. You can crop an image as well. Now what you need to do is you need to feed in 4 parameters, the left, top, and right bottom. So let's just go up here and let's see what that's going to do. So basically the left top, say we have a point here, and the right bottom, we have a point here. These 2 points are going to form the 2 opposite ends of a crop rectangle or a crop box. So if you have a point here and you have another point there, you can think of it as the 2 opposing ends of the diagonal of the box. So if we go back down here, let's see, 50, 120 will be the left top, and 250, 230 will be the right bottom. So 50 will be around here, 120 will be around here, so that'll be the left corner, left upper corner, and then 250, which will be around here, and 230. So we're just going to be cropping out a small piece of the ear. So let me just run this, and there we go. So we get a small piece of the ear. So this is just cropping an image. Alright. Copying, you can also make a copy of an image. Sometimes you want to make transformations to the image and you don't want to disturb the original image object, so you can make a copy of it. And it's very simple, image.copy. And now we have a copy of an image and we're displaying it with PLT IamShow. Now transposing. Transposing allows you to change the orientation of an image. So let's see what the different types of changes we can make. We can flip from left to right. So everything on the right side is going to be displayed on the left side. So you're going to be essentially reflecting everything on the y-axis. And you'll get a better understanding of what that is when I run the command itself. Alright, so you have flip from top to bottom. So you're going to essentially be flipping it upside down. So it's going to be reflected on the x-axis. Then you have a bunch of rotations, 90, 180, 270, and transpose, which is converting the rows into columns. So if you've taken linear algebra courses, you're just taking the transpose of the matrix, which is taking the rows and turning them into columns and taking the columns and turning them to rows. All right, so let's just run these so we get a better understanding. Okay, so from flipping from left to right. So what happens is everything that was more on the right side gets flipped onto the left side. So if we look at this cat, you can see like the paws were more towards the right side. And here they're more on the left side, sort of like a reflection. So we have the flip top bottom, which is just a reflection over the x-axis, so it's upside down. And the rest are just rotations. And the final one is just a transpose. So the rows become columns and the columns become rows. Now resizing. You can resize the image in terms of the width and height, and the function accepts a tuple pair that is the new size of the image. So resizing, you just give it the size of the image you want to change the image into, and it's going to be in a tuple form. So the tuple is going to represent the width and the height. Now, when you resize, there's actually various different algorithms that can be used to how you should do the resizing. These are some of the algorithms or interpolation techniques that you can use. So you have nearest, box, bilinear, Hamming, bicubic, and I'm not really sure how to pronounce this final one. So these are just different algorithms as to how you're going to resize the image, right? So the simplest one is nearest, but the quality is pretty bad when you use nearest. I've personally never used box. Bilinear I've used, which is pretty decent quality. Then you have bicubic and this final one. So these final two are some of the better algorithms to get a much sharper image. However, now with deep learning, there are also deep learning interpolation techniques, which I think are producing the best looking images. So I'll have to play around with that and see. All right. So once again, we're going to just run all of these within a bunch of subplots in matplotlib. And let's see. All right. So the orientation or the aspect ratio is kind of screwed up. I've changed the size to 300 by 300. But if you can see, you see the nearest is not as sharp as bilinear. A bicubic is supposed to be more sharper than bilinear, and this one is supposed to be the sharpest. The worst looking one is nearest, and everything else looks pretty good. I usually use bilinear, which is pretty good. Bicubic is supposed to be better, and this one as well. I can't really tell the difference. Actually, I can. It looks a little sharper than this one. Actually, this one kind of looks the best. But these are all different interpolation techniques. You guys can play around with them. All right, rotation. Earlier, we used the transpose functions or methods, but you can actually rotate using the image.rotate method. So here you feed in the angle, and you can rotate your image based on that angle. So here we have angle 30 degrees. So you can see we're rotating the image 30 degrees. And here we're going to rotate negative 30 degrees, which is going to rotate the opposite way. All right, next up, text watermark. Now you can actually add watermarks to your images in the form of text. Now you'll see if you've been playing around with images, you'll notice that a lot of photographers like to put watermarks like text watermarks or image watermarks or some kind of symbols, graphic designs on their images so no one can steal their images without paying for it. So here with PIL, we can actually create text watermarks. All right. So to use text watermarks, let's just get right into it. First, we're going to make a copy of the image. Now this imageDrawer.draw allows us to make our image editable. So we feed in our image, which is the watermarked image, and we get a draw object. So this draw object allows us to make edits to our original image. Now the font, now we also need to create a font object, which is actually an image font object. And within the image font object, you feed in the type of font you want to use and the font size. So the type of font we're using is Arial, and the font size is going to be 100. So we have now our font object. And finally, we're going to draw on the image itself or make changes to the image itself. So we have draw.text, which allows us to write some text on the image. And 0 by 0 is the position or the coordinates of where we want to start writing the text. Then we have sample text, which is going to be the text that we're going to write. 000 is the fill color. So when you have the text, it's usually just the outline of the text, and you can fill it with any color you want. And in this case, we're going to start off with white, and then I'll show you an example with black. And then font equals font. You just feed in the image font object that we created. So once again, this might be a little confusing, so let me explain it once more. First, we make a copy of the image, so we have a watermarked image. Then we feed this into the imageDraw.draw. What imageDraw.draw is doing is it's taking our image and making it an editable image. So now we have a draw object, which is basically an object that can be edited. And the next thing we want to do is get the font. So we use imageFont.TrueType, and we fit in the type of font we want to use and the font size. And now we have a font object, and we feed that into the draw.text method. So the draw.text method has 4 different parameters. The first one is the position where you want your text to start, which is 0, 0. So it's going to be the left corner of the image. Then we have the text that we want to write, followed by the fill color, which I'll show you guys in a second, and followed by the font. So let's just run this. So the fill color is currently 0, 0, 0. As you can see, we have sample text. So now we're going to change it to 255, 255, 255. So the new fill color should be white. Sample text is now white. All right, so now not only text watermarks, we can also have image watermarks. So we're going to be doing this using paste. All right, so if you look at the code block, you'll see the size is going to be 500 by 500. We're going to make a copy of the image called crop image. And now this thumbnail allows us to create a thumbnail of the image. Now this is different from resize or crop in that it actually preserves the aspect ratio. So even though we're feeding in the size 500 by 500, I think it only takes the first parameter 500 and makes sure to keep the aspect ratio intact. So this crop image is just going to be a thumbnail of our original cat. And now we're going to create another copy because we're going to be pasting this crop image onto the copied image. All right, so if you look at the next command, we have copied image dot paste. So we're saying that the copied image is the base and we want to paste on top of it the crop image. And the 0.0 is just the coordinates as to where we want the crop image left corner to start. So if I run this, you'll see that it starts at 0.0, which is the left corner of the cropped image, and we're able to paste the cropped image onto the base image, which is copied image. Next up, converting to black and white. So we can take an image and convert it into black and white. And it's very simple. You just use image.convert and feed in an L. I forget what L stands for, but in this case, it's going to represent a black and white image. So now we have a black and white image and we feed it into plt_im_show. And you always have to use cmap equals gray to display the correct color mode or color map, if I'm not mistaken. And here we have a black and white image. All right, so not just black and white, as we touched upon earlier in the video, you can convert it into different modes. Now, HSV is another color mode as opposed to red, green, blue, RGB. And when you start playing around with computer vision and deep learning, you want to convert it into different modes because some of these different modes will bring upon better accuracy for your classifier models. All right, number 14. Now we can convert the image object into a NumPy array. So you just feed it into NP array and you feed in the image. So it converts the PIL image object into a NumPy array. And the other way, which is the reverse, you can actually take a NumPy array. So if you have the image pixel values and you want to convert it into an image object, you can do so with image.fromArray. So I guess we'll just run these two. So here we have an image array. And you'll see that the 867 and the 1300 have been flipped because NumPy does height and then width, as opposed to PIL, which does width then height. If I run this, we converted back the NumPy array back to an image, and we're able to show the image. All right, so next up we have image enhancement. So image enhancement is just changing certain properties of the image. So you can change the color, you can make the colors more enhanced, the sharpness more enhanced, contrast, brightness, etc. So let's just take a look. So we have from PIL, we're going to import image enhance. Once again, we're going to make a copy of the image, and so all you need to do is call the image enhance module, and then you have the options of color, contrast, brightness, or sharpness. And within the constructor of those, you can feed in the image. And after you feed in the image, you call the enhance method and you feed in a parameter. Now, 1.0 is the default. So if you feed in 1.0, you're going to get back the image as it originally was. Anything above 1, you're going to be enhancing, and anything below 1, you're going to be decreasing or subduing, I guess. So here we're going to enhance everything. So we're going to enhance the color by 2.5, enhance the contrast by 2.5, the brightness by 1.5, and the sharpness by 2.5. And we'll take a look at all of this and see what changes these, and we'll see what changes these methods bring along. So the color has been enhanced. There's more, I guess, sort of a orange type tinge. The contrast has been enhanced as well. You have the brightness. Let's just see. I'm going to increase the brightness by 4.5. So as you can see, I've made it really bright. Sharpness. So you could see some of the edges, like the whiskers, are a little more sharper. I guess the ears pointing. Can't really tell. I guess some of the polka dots, I guess some pixels have been more sharpened. I'm not really sure, but yeah. So these are the 4 enhancement methods. Alright, so now what I'm going to do is subdue some of these. So the color I'm going to just reduce instead of enhancing by 0.5, and contrast as well 0.5, enhance 0.5, 0.5. So the brightness, sharpness, everything is going to be subdued. So let's just take a look. Actually, with sharpness, if I do something like 0.1, I would imagine it'll be more of a blurring effect. So let's just take a look at that. Alright, so the color, I guess it's turning more black and white. Yep. The contrast is changing as well. The brightness is a little darker. And the sharpness, I am not really seeing a change in this. But in comparison to the above picture, see here, some of the whiskers are, I guess, standing out more as opposed to here. I'll have to play around, but you guys can play around with sharpness and see what you figure out. Alright, next up, alpha blending. Alpha blending is the mixing of 2 images. So it's the combining of the alpha channel with other layers in the image in order to show translucency. Alright. So basically, you're going to be blending 2 images together. And the formula is image 1 times 1 minus the alpha plus image 2 multiply the alpha. So if the alpha is 0, you get a copy of the first image. But if alpha is 1, you get a copy of the second image. So anything between 0 and 1, you'll get a blending of both images. So anything closer to 0 is more towards the first image. Anything closer to 1 is more towards the second image. So if you do something like 0.2, you'll get more of the first image and less of the second image. So I guess 0.2, maybe 80% of the first image. I'd have to do the math, which I can't do at the top of my head, but anything closer to 0 is more of the first image. Alright, so there are 2 rules in order to blend 2 images. You have to make sure the images are the same size, and you have to make sure the images have an alpha channel. Now, usually a PNG format has an alpha channel, which stands for the transparency or translucency. But I think JPEGs as well. From running my examples, JPEGs seem to have some kind of alpha channel as well. Alright, so let's just run this and you'll see what I mean. Okay, so we make a copy of the first 2 images. Alright, so now we're going to resize image 2 to be the same size as image 1 because that's one of the criteria. So now the blending. So we're going to blend image 1 and image 2 and we're going to use 0.5. So 0.5 sounds to be right in the middle, so we should get a perfect blend between the 2 images. Alright, so here you'll see a pretty cool blend of the cat and the sky blended in together. So that's what alpha blending does. Next up, image transforms. Now, this is a kind of complicated subject. It involves a lot of linear algebra, and I don't think I'll be able to explain the math just quite yet because I haven't really looked deep into some of these transforms. But an affine transform is basically changing the perspective, and the extent transform is just going to blow up a certain section. So it's going to crop a certain section and then resize it to fit that size of the image. What extent transform is, you're either shrinking something or zooming in on something. Now there's a quad and mesh, which I'm not going to go over in this video because I haven't really played around with those 2. So we're going to look at affine transform, which is the one I'm most accustomed to. Now the way you create an affine transform is you feed in 4 parameters within the transform.transform. So the first parameter is the size of the image. The second parameter is the type of transformation. The third parameter is going to be the matrix values for the transformation, which is a 6-value tuple for the affine and a 4-value tuple for extent. And the fourth parameter is the type of interpolation you want to do, which is optional. All right, so the formula for the affine transform is it's going to take 6 values that you feed in, which is A, B, C, D, E, F, and A, B, C is going to be used on the X pixel value, and D, E, F is going to be applied to the Y pixel value. So hopefully you guys, of course, know. So each image is basically like a grid consisting of a bunch of pixel values and the height consisting of pixel values. So something like 0, 0 would be the 0 width and 0 height, and something like 30, 30 and 35 would be 30th pixel value width and 35th pixel value of the height. So here what we're going to be doing is we're going to take that 30, the pixel value of that 30th x value, and we're going to be changing it with the formula a times x plus by plus c, which brings upon the affine transform. Now, I'm not really sure why this works to create an affine transform. I would have to go back and look at the formulas and see exactly how these linear transformations are occurring. So that's the affine transform, and then we have the extend transform. So let me just run these. So the first one is going to be an affine transform. So I actually got some of these values from Stack Overflow, but if we look at it, you'll see that the y values are not going to change. So we have 0, 1, 0, and if we go up here and look at the formula, this is just d times x plus e times y plus f. So the y value is affected by this entire formula. But if we make d 0, that means this cancels out, and if we make f0, this cancels out. So we'll only have e times y, which is 1 times y, so we're only going to get back the y value. As opposed to ax plus by plus c, we're going to feed in a bunch of numbers, 1, negative 0.5, and 0.5 times the size of the width. And if I just run it, you'll see that it's creating a kind of pretty cool perspective transformation. All right, now with image.extent, what we're doing is we're feeding in the type of transformation we want to do and the values. So essentially what it's going to do is it's going to crop out this entire box. So 100 by 100 is going to represent the left side again, the left x and y values. So this 100 by 100 is going to represent the left side coordinate. So remember in the early examples when we were cropping, we fed in 4 different values, and the first 2 values represented the left side of the diagonal, and the last 2 values represented the right side of the diagonal. So same thing, this 100, 100 will represent this point. And image transform 0, which is the entire width, and image transform 1 divided by 2, which is going to be half of the height. So we're going to crop out a certain portion of this cat image, and we're going to zoom it into image transformation size. So what image extent is doing is you crop out an image and then you zoom it to the original image size or the size you feed into. So if I run this, we cropped out the head, and you'll see it's zoomed in to be the original size, which is, I guess, 800 by 13 something. I forget the size. So extent is just zooming in. All right, flipping channels. So you might need to sometimes flip channels, especially if you're using something like TensorFlow and PyTorch. You'll need to reverse RGB to something like BGR, and you can do that in PIL. So the way you do that is here we just made a copy of the image and use image channels.split. This is going to split the 3 channels. So this actually splits the channel, and sorry, so this should actually be red, green, blue. So this is a typo. Okay, so it should be red, green, blue. So you're going to be splitting the RGB into 3 different channels, red, green, blue. And let's see, we want to merge them back together. So say we want to merge them back in the opposite order. So blue, green, red. So we're taking the image, we're splitting the channels, red, green, blue, and then we're merging them back together in the opposite order. So this should be blue, green, red. So this format should be actually RGB. RGB. All right. So what we're essentially doing is we're converting back to RGB format, but we're switching around the channels. So instead of having red, green, blue, which is the red channel representing red, we're having the blue represent the blue channel coming first, the green channel coming second, and the red. So essentially flipping the channels. So if we run this, you'll see now we've converted the RGB channels into blue, green, red. And this RGB is just the format. So it's telling you what kind of format, because you have RGB format, you also have the HSV format, and various different formats. So we leave it as the RGB format, which is the mistake I was making, trying to change that, but we're going to use the blue, green, red. So once again, all we did was we split the channels using image channels.split, and we got the RGB. Then we flipped around the channels, or permuted the channels as to how we wanted it, which was the blue, green, red, and we told image when we're merging it, what mode this is. So since we're dealing with the RGB channels, that's the mode we feed in, RGB, and we feed in the 3 channels that we want to merge. And here we have the display of the image with the channels flipped. All right, so that's it. So this was actually a 2-man job because it's a pretty lengthy tutorial, but hopefully you guys enjoyed it and found it useful. All right, I will see you guys next time.